guys, we're jumping into practice problems for 1.6. This is problem number 1. We're starting to discuss area now. And we're going to do a drawing of this figure with a factor of 2. So that means all of the side lengths are going to double. So, you know, this 1, 2, 3, 4, 5, this 6 length side is going to become 12. This 2 length side is going to become 4. And this 4 length side is going to become 8. And that's going to become a 6. So let's draw this. Let's start kind of down here in the corner. Alright, and we'll start with that 3 down there, corresponding 1, 2, 3, 4, 5, 6, because everything got doubled. Going up 1 means up 2. So far I have drawn that line and that line. So I will correspond that with a red here. So over and up. And let's do a couple more. Let's do these in green. We'll go with 4. These go over 8. So 1, 2, 3, 4, 5, 6, 7, 8. So far it looks like we're going to be able to fit this thing on here. So that corresponds with the 4. And then up 2 means I'm going to go up 1, 2, 3, 4 on my scaled by 2 version. So that measures with that one. Over 6, that means I've got to go back 12, so that's a big jump to come back 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 is right there. So that is the side that corresponds with this blue up here. That was 6, now it's 12. Down 1 means I'm going to go down 2, right there. Over 1 means back 2. And that makes sense because it gets me back to the edge. So those were my down and overs. And then we got to go down 4 to complete the sides. And it makes sense because it was 2. Alright, so compare the perimeter. Well, the perimeter of the first one, if we look at it, is 6, 2, 4, 1, 3, 2, 1, and 1. So we add all that together, we get 3 from the 1s. So 3 from the 1s there, plus the 3 right here, 2, 4, 6, and another 2. You know, that's the perimeter because that's all the sides added up together. 6, 8, 12, 18, 20. So we go around 20. So the perimeter of this one is 20. Now, what do you think is going to happen if I just double all the sides? I don't even got to count these bad boys. That perimeter is going to be twice the length. It's going to be 40 because everything just got doubled lengthwise. So, you know, what was 1 is 2. It's like taking all of these and just making them twice as long and adding all that together. And there's no sense in me going through that process. It's pretty obvious that it's just going to become 40. But area is a different animal. We talked about that in class on Wednesday. And, area doesn't work the same way. In fact, area is how many boxes are inside. So let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The area of the smaller one is 16 square units. Now the bigger one, you would think, hey, maybe twice as big, twice as many boxes. Not the case. Let's look at it and compare. 1, 2, 3, 4, 5, 6 by 2, that's 12 in this section right here alone, right? And then we know that this is 12 long by 2, so that means this section is 24 right here. And then we've got 12 plus 2 more is 14 by 2, so this is 28. So there's 28 in this section. So you add all that up, 30, 40, plus this is 64. So I've got a 64 boxes inside of this one, and there were 16 in that one. The relationship here is not times 2. What is it? Well, we talked about this in class. Okay, you take the scale factor that works for your sides, which we know is times 2, and you square it. So that means that 2 squared, our area factor is going to be multiplied by 4. And if you do it, you'll see it's true. 16 times 4 is equal to 64. 2 there carried. So it makes sense. You multiply by 4 whenever you scale a factor of 2 area, because you are scaling the length and you are scaling the width. And that's the end.